Hey everyone, we've gotten multiple requests to cover AV evasion in our previous video, and at last, here it is. So sit back and relax because we're getting started. Attackers are constantly creating new forms of malicious software, pushing the boundaries of what can slip past modern defenses. That's exactly why antivirus software exists, but how do attackers stay one step ahead? In this video we dive into the world of AV evasion. You will see how ethical hackers bypass Windows Defender to remotely access PCs. By the end, you'll have a solid understanding of how antivirus software works and grasp the core concept behind AV bypassing. At a high level, antivirus works like this. It stores a local database of malware signatures. When a new file is run, its signature is compared against the ones in the database. If there is a match, the file is quarantined or removed. If not, the file usually runs. But most AV solutions also have cloud analysis environments where suspicious files are sent for deeper inspection. In the cloud, it can take hours, days, or even weeks for malware to get flagged. Once it does, the signature gets added to the database and the specific bypass is now mitigated. That's the general high-level cycle. The time between when the malware is submitted for analysis and when its signature is added to the database, that's the window when our malware can bypass AV solutions. To take advantage of this, we need to build malware that doesn't have a known signature yet. There are several ways to do this, but today we'll do it by writing new malware from scratch. Okay guys, now let's finally get hands-on. The goal here is to write an entirely new reverse shell program from scratch. Since the payload will have just been created, it will be unknown to the world, meaning the offender won't have a signature for it and will not have analyzed it before. This increases the likelihood that the payload will run without interruption. We'll be building our bypasses with C#. Before we start writing code, we need a development environment. I'll be using Visual Studio. Feel free to skip forward if you have your IDE ready. If not, I'll walk you through setting up Visual Studio 2022 on Windows. Open a browser and search for VS 2022 download. Choose Community Edition. Run the installer. Once you get to this menu here, select this one and click Install. You can sign in if you want, or just keep it for now. If you see this window, you're ready to start. Now that you have Visual Studio installed and you no longer need an internet connection, it is a good practice to turn off the internet to prevent Defender automatically sending samples of our malware while we're developing it. As you can see, I've restarted my virtual machine and turned off the internet. If you're using VirtualBox, here is the setting I have selected. Later on, when we need an attacker Kali machine, we will also select this host-only adapter option for our attacker machine as well. This way, the attacker and victim machines will be in the same network and will be able to talk to each other, but both will not have access to the internet. With that out of the way, let's create our project. Choose Console App. Name your project. Enable Native AOT Publish. This will make sure our final payload uses ahead-of-time compilation instead of just-in-time compilation. This is a .NET specific thing. If you're interested, you can research it. I have also checked this box, which will create our program class and our main method. Hit create. And here we have our Hello World application. Our goal here is going to be to write a reverse shell. Before we start executing any commands, let's figure out how to set up a simple TCP connection. Let's define the IP and port of our listener. I will fill in the address later. Now we can set up the TCP connection. Here, if you have not done this before, you can look it up online, ask ChatGPT, or look up documentation. Our goal is to connect to a TCP listener. I have already researched how this would happen in C# and I will show you now. First, we'll create our TCP client object. Next, we'll grab the stream of this TCP client so we can read and write to the TCP connection. We will set up our reader and writer stream And now we are ready to talk with the server on the other side of the communication. Let's read a message from the server and let's print it out for debugging purposes. Let's also read a line and send it back to the server. This reads from our console locally. And let's write it to the stream, which will send it to the other side of the communication. Finally, let's close this in an infinite loop so we can repeat. Okay, great. I will pull up my Kali machine now so we can test this. The Kali machine's network setting is also set to host-only adapter, so these machines should have connectivity. Let's verify that. Great. Let's specify the address. Let's set up a netcat listener. And let's try running our program for the first time. Great, our Windows machine successfully connected to our Kali machine. Let's try to use the TCP connection. If we try to send something from the server to the client, as you can see, from the server we send it and the client received it. Let's type something here on the client side. Our server can send data to the client, but the client doesn't successfully send data to the server. The reason for that is that we need to flush the stream every time we write to it. Let's enable auto flush for the stream writer. And let's try again. This time, if you try sending something to the client receives it. If you try to write something from the client to the server also receives it. If you think about it, this is the exact network functionality that we use in a reverse shell as well. The server sends something, the client receives it, but instead of writing it to the console here, it sends it to a session, to some sort of PowerShell session, which executes it, returns the output, and then the output is sent like this. Instead of sending whatever we write here, the output of the command is sent back to the server. Now that we have this network functionality working, our next step is to set up some mechanism that receives a command, executes the command, and returns the output of the command. Then we can simply plug this functionality into this code. Instead of writing the server message to the console, we would execute the server message, and then instead of reading the client message which we send back to the server from the console, we would directly send the output of the command back over the TCP connection. Hopefully everything is clear so far, guys. If not, definitely feel free to ask in the comments. Okay, we're back to our Windows development machine because we gotta write some more code. We will now implement a mechanism that keeps a persistent PowerShell session available to us. Whenever we need to, we would be able to send a command to the object and it would return us the outputs. Then we would simply interface this persistent session with this logic here. For the purpose, let's create a new class. Let's first define a few fields. We have a field for our PowerShell process, and we have two fields for the standard input of our PowerShell process and the standard output of our PowerShell process. Let's define a constructor that will initialize these values. We will now define a process start info for our PowerShell process. These properties I saw in the documentation. We are defining that we will be redirecting the file descriptors. We will not be creating a window for our process. And this option is also needed to be able to redirect standard in and standard out. Let's start the PowerShell process. If for some reason our process didn't start correctly, let's exit the program. And let's also initialize our fields for standard in and standard out. They're available from the process object we have here. Okay, great, now we have our PS shell ready. What's left now is to define the logic that will execute a command through this PowerShell session. Let's set up a public method to do that. The method takes a parameter, which is the command we want to execute, and returns a string, which will be the output of the command. Well, with our current setup here, in order to execute a command using this PowerShell session, we just need to write it to standard in. We will also place a marker in the output buffer using the echo command, so that when we later read the output of the command, we know when the command finished, or rather where the output of the command ends. I think this will become more clear in a moment. This will just be printed on the buffer of the output, and we would know where this command, the previous command, finished, or where its output ended. Let's not forget to flush the stream as well, because you saw what happened when we didn't flush it earlier. Okay, great, we should have successfully sent our command over standard in, and it should have successfully been executed. If it was executed successfully, hopefully our output should be sitting in the standard out file descriptor. So now let's set up logic to read out of the standard output stream. We'll set up a string builder for our output. We'll define a variable for holding the current line, and we will iterate the lines of standard out until we reach a null. And here, if the line we are currently on is the end marker, we know that the output of the command that was executed has finished there. So we can exit the loop and stop looking for more lines. And if the line was not an end marker, it was a valid line of the output of the executed command, so we add it to our string builder. Also, by the way, I just realized I was writing this in the wrong method, so let's quickly move it. There we go, sorry about that. Now let's save our result to a variable, and let's stream white space as well to make it cleaner at the end. And let's return the result. That should be it. If you notice, guys, we are not handling standard error, we are not reading from standard error, and we don't have logic to return output that was sent to standard error if there is an error and standard out is empty. The reason I didn't implement it is to keep it simpler and hopefully easier for you to understand. I even challenge you to implement standard error logic in this reverse shell for it to be even more polished. But anyway, let's now test our new type. I'll go back to program, and for now I will comment this out, we will use it later. Let's create a new object of our type, and let's try it out. Let's write out to the console session.execute command, and let's execute, for example, who am I? And let's see what happens. As you can see, the command successfully executed and we have the output here. But something annoying is that we can see what the object actually ran for us on the PowerShell session right here. So let's go back to our type definition and remove any lines starting with PS so we don't see these lines of the commands being written out. Let's try it out now. And now it is cleaner. Let's simulate a normal PowerShell session now. We are just reading from the console, executing the command that was read and writing it back to the console. Let's try that. Let's type who am I, and we get the result. Let's type dir. And as you can see now, it is working like a normal shell. Let's try going back a directory, and as you can see, that works as well. That is one of the main benefits of setting up a persistent PowerShell session, because otherwise we wouldn't be able to change directories like that. If you have watched our VirusTotal video and remember, we actually had that problem there. Okay, great, we seem to have a convenient way to interact with a PowerShell session and execute commands through it in our C# code. The only thing left is for us to set it up so that the remote server sends a command, we execute it locally and return the output back. Let's remove this for now. Let's move this on the top of our code here, and let's uncomment this. Instead of writing the server message out to the console, Let's execute it via our new session object. Let's also name our variable something a bit more suitable, like command or cmd. Great, we now should have our command output stored in this variable, so let's write it back to the remote connection. And we don't need this client message variable. Remember, we don't have to flush this stream because we have set auto flush to true. We have a warning here. It is complaining that cmd may be null here, so let's do a null check and set it to a default value of an empty string. Okay, awesome. I'll bring the callback and let's try it out. Let's set up our listener and let's run our program to see what happens. We got a connection. Let's try running a command. As you can see, we get the output. Let's try something else. As you can see, it is working quite like a reverse shell. We can still polish a few more things. For example, one of them, if you notice, the first command we type, it first prints this PowerShell message and then it prints our output, which is a bit annoying. What we can do to fix that is press enter once, like this. If you notice, if I hit enter once, this message pops up. So let's automatically send this new line from our agent here. We just literally execute a new line, simulating pressing enter. Let's try it. As you can see, now it pops up like that. And now the reverse shell works like normal. We could print a prompt here that lets us know we are in a shell, similar to what we did in our reverse shells video. Notice I'm using write instead of write line, so that we are prompted on the same line where this is written out. Let's try it out. There we go. We could also make it a bit more prettier by writing out the current working directory in the prompt here, like a real shell. Maybe a format like that would look good. We are simply executing the print working directory command, and because the command outputs 3 lines, we split the output by new lines and we grab the last line, which is the current working directory. Let me show it to you guys. If you do print working directory, you can see that we get this line here, this here, and then we get our current working directory. So what we do on this line here is we split this output by new lines. So we have a new line here, new line here. We split it into new lines, and then on the resulting array, because the split method returns a string array, from the resulting array we grab the third element with index 2, which is going to be this line here. Okay, let's try it out to see how it looks. And now it looks like a real shell because we have our current working directory displayed like this. And it is more convenient. For example, if we go back directories, we immediately know where we are. One issue we might have here is if we try to exit, our program crashes in an inconvenient way. Let's add a command option for exiting and just break out of this loop. Let's try it out quickly. It closes gracefully. And the last thing, we obviously don't want our victim to see this big black window when we run our reverse shell. We can disable this from popping up by opening our Solution Explorer, right-clicking on the program here, on the project, Properties. Now here we have output type. Instead of console application, we select Windows application. Let's try it out now. As you can see, there is no trace of the black window and we still get our reverse shell. Now that we have our program ready, we need to compile it into a standalone native Windows executable, so we can execute it without any dependencies on the .NET framework or any other DLL files living in the same directory. To compile a standalone executable, we'll go to View, open a terminal, and run the following command. We are publishing in release mode, choosing the x64 architecture, telling it to produce a self-contained executable with AOT mode enabled. It tells us where the binary is gonna be, so let's open the project folder. And here we have our program. Now this executable is going to be the AV bypassing reverse shell. I'll copy it, I'll close this, and I'll paste it to the desktop. Let's make sure Defender is running. What I'll do is I will disable for a moment automatic sample submission and cloud delivered protection, because right now we are connected to the internet and we don't want Defender submitting our binary for analysis and catching it faster. In a moment I will also enable these, just to show you what happens and that it still works. Here I have the Windows and Kali machine side by side again. Let's test our bypass with Defender enabled. By the way, I changed the port to 443. The reverse shell now connects over 443. So I will run it and let's see what happens. As you can see, with Defender enabled, absolutely no problem. We get our reverse shell back and can do whatever we want. Now I will also turn on sample submission and cloud delivered protection on, but keep in mind guys, if you're developing a bypass, never turn this on and never even be connected to the internet in your development environment, because once this sample gets submitted to the cloud for analysis, sooner or later it's going to get detected. Let's try it again. And we see absolutely no problem. I'll do one last experiment and submit the file in VirusTotal for analysis. But make sure guys to never submit payloads you want to keep undetected to VirusTotal, because VirusTotal submits whatever you upload to VirusTotal, it submits it to all vendors for analysis, and submitting a file that is undetected to VirusTotal is the best way to get it to be detected very soon. As you can see, it is almost fully undetected, with only 2 out of 72 security vendors flagging it. Okay guys, it's me from the future. It has been 3 weeks since the recording of the last segment. Let's see what happens to our binary now. Going to place it on the desktop. And as you can see, now it is detected. Cloud Engines had enough time to analyze the binary, and it is no longer going to work as a valid bypass. At this point we need to repeat the process and create new malware. As you've seen, AV evasion doesn't really require complex tricks or targeting specific detection software. Sometimes simply writing some malware from the ground up, something new and previously unseen, is enough to slip past detection. Antivirus bypass is a broad field with a variety of techniques and tools available. In this video we demonstrated just one method against one AV solution. This wasn't about showing every possible bypass, it was about showing how to think about the problem. Hopefully this sparked your creativity and inspired you to come up with your own clever solutions. Thank you for watching, see you next time.